What's up, Internet? It is I again, that guy again, and today we're going to be doing we're going to be starting off the Kingdom Hearts 2 hack through. And this is going to be reminiscent of those early 2010s playthroughs where, folks would play through the game and give color commentary, except I'm going to be hacking the game and showing you guys how I do it while I do it. So, yeah, with that said, let's begin. We're going to play critical mode because we're really good at this game and we're also hacking, so, like, why wouldn't we? But anyway. So, let's see. We're going to go ahead and skip all the cutscenes at the start. This isn't necessarily a speed run, but like, why would I play vanilla cutscenes for y'all when they're not hacked? When we start hacking the cutscenes, we're going crazy. But that's a ways away. Alright, so here we are. We are in Twilight Town, sorry. I'm just curious how far you can walk off. Is there even anything to do over here? Nothing. I'm kind of curious, like, what we should start hacking first, but I wonder if, like, health or something might be easiest. We have to get to a fight, though, for that, so... yeah, let's just go through and get to the first fight. We'll just skip through everything until then. I could be a speedrunner. Bam, look at that speed, that accuracy. It's all about speed, it's all about power. Oh, cool, we're at the first fight. Okay, so like, I just want the regular bat. Just want to beat the guy with a bat. This will do. Strength +1. Ooh, maybe we could have searched for strength with that. It's okay. So health is going to be really easy to search for, right? So I don't know what they store health as yet. It's easiest to assume it's a bite because I know that my health is going to be less than 255 by now, right? So I had to sip some coffee. So we're going to do our first scan. Ooh, I made a critical mistake. So I'm going to say new scan. We're going to get rid of that scan. And we're going to only scan the Kingdom Hearts 2 Final Mix.exe memory space, right? Oops. We want to do unknown value. Alright, first scan. There we go. There's 34 million bytes, almost 35. So now we're going to say unchanged value. I'll just pause, run over here a little bit, make some stuff happen. Alright, cool. We're only looking at unchanged bytes. So now,
don't leave me hanging now.
Let's let him hit us.
Don't leave me hanging now.
Bro, don't leave me hanging. Hit me with your baton.
Don't leave me hanging.
Okay, fine. Will you hit me now?
Don't leave me hanging now. Yeah.
Okay, cool. Unfortunately, we have one. Oh, maybe now he'll actually hit us. And one thing I also see we could do real quick, right? We know that our current health is not currently 0, because if it was, we'd be dead, right? So we could say exact value 0, toggle the not filter, so everything that's not 0. Next scan, that got rid of millions. That's tens of millions. Yeah, it's ballin'. Okay, so now that that's done, let's say unchanged value. Walk over here, next scan. Alright, sick. So let's let him hit us. There we go. Decreased value. We don't know by how much, but we know it was decreased. There we go. Alright, cool. So now we could say unchanged value scan, because only 4,000 different values that it could be now. Unchanged value scan. Very cool. Let's let him hit us again. He missed. There we go. That's amazing. Okay, so now decreased value scan. Only 112 values, right? So we could kind of feel through here and see, right? Because this rightmost column is first. This is the first value it was when we first scanned, which should be our max health, right? So it's all about finding values that look like they would be our starting max health. I mean, it's a lot of zeros. We obviously didn't start at 0. A couple 20s. It's a lot to fish through. Let's do one more scan. Let's go through. Let's just say unchanged value. There we go, 21. Okay, very good. So actually, out of all of these, right, I see there's 2 that are 20. I mean, yeah, maybe we had 10 starting health, doubtful, but maybe. Let's try this one. That's currently 10, let's set it to 20. It got set back to 10. Let's try this, right? Let's try this. Let's delete this one. Let's try setting this to 20. There we go. That's our health, right? So now we know this is like health, right? Like, I mean, we don't know if it's always going to be our party health or like anything like that, but what we could do is we could say, I like to go browse this memory region, and then it's actually interesting, right? This might be like your max health right after it. Let's try something, right? Let's set that. Oh yeah. So max health comes right after it, basically. That's cool. Okay. So anyway, 1-4. Let's say data breakpoint. Find what writes this. Oh no, break on write. Sorry, break on write, because that'll actually stop the game when it gets changed, and we can look at the code as it happens. So it's actually crazy, right? Because you can see this is the frame it froze on right there. That's the frame we took damage. The exact frame we're taking damage on, right? Like we just took 4 points of damage there, it looks like. And so, surprisingly enough, right? He's not even. Let's go back to it. Oh, you can't here. He's not even touching us yet. So there must be some kind of like invisible collision, I guess, or something. Yeah. Anyway, so this is the code that actually wrote it there, right? Because you can see the A register racks has 10 in there, 10 hex, which is 16, which is the new value of the what would you say, the memory region or memory address. And if we take a look a little bit at the specific line of code that wrote that, right? Move into basically removing the value stored in the A register, right? In the like last 4 bytes or the last half of the RAX register, that's EAX, right? Which equals to this 010, or it's like 4 bytes basically. 4 bytes, 3 zeros and a 10, so you'll see 3 zeros and a 10, right? And if we were writing this one, it'd write 3 zeros and a 10 in there instead. But we're writing this one right now. That's just kind of like what the EAX is compared to RAX. RAX 8 bytes, EAX is 4 bytes, and so on and so forth, right? But we're taking the value in that EAX, right, the 4 bytes of RAX, and we're putting that into the memory address that you would get from adding the value in the C register, right, which is this 3018 memory address, right? And then you would take that's like the base of an array usually if you see it like this, right? Or a base of a memory structure. And we're adding the R8 register, which happens to be 0, multiplied by 4, right? And the reason it's by 4, these are all 4-byte values. So it's some kind of list. And to be real, it almost looks like there's only 2 different values, like current health, max health. I don't know what else there would really be. But it almost seems as if it's going through and it's just, R8 is like the value of the index of like which int to write from this RCX, So RCX is definitely like this 3018 is definitely like where this starts at, like where your health stat page or statistics page or whatever you'd call it would start at. But for whatever reason, like there's got to be more to your character than just this, I would say. Now what we might become curious of, right? Like if we scroll up here, we see like an int3 and a return and like all this stuff. So like, I mean, this is part of some greater function, right? Like it makes you wonder, like, how do we get RCX, right? So like if we're looking back through RCX, oh, hold up, LEA, oh, yeah, we must have come from somewhere else here. We must have come from somewhere else. So let's do this, right? Let's step into, because we were actually at the end of that function anyway. So this is where we would have been before this function ran. And actually, move into RCX, the value stored by RBX plus 5CO. And there's a chance that RBX isn't the same anymore. So what we'll do is we'll just delete the original breakpoint. We'll put one on this line of code. And we're just going to run the thing.
Don't leave me hanging
Supposedly
now.
when we take damage, that should run. So we're going to take damage again.
Isn't this romantic?
Very romantic. All right, amazing. So RBX is this A280 memory address, right? So if we go through A280, and it says plus 5CO, then we get a pointer, and that pointer is the address we were looking at. So that's how it gets to it, right? It goes from this entity start, right? Here, so like entity, right? And then for the entity structure, so to speak, at +5 CO of an offset, there's an 8-byte pointer to what we'll call a stat page, right? And then we'll say down here in our little notes, right, stat page, right? So +0, 4-byte, oh wait, let's keep our format, 4-byte, current HP, right? +4, 4-byte max HP, right? And it's really helpful to keep notes like this, to be honest, because there's a lot of very nested data structures, right? And you don't have to keep notes in the same way that I do. Like, I honestly keep notes in a variety of ways, and none of them are like typical notes. Like, this is the first time I'm keeping them like this, but it's very helpful when you're going back and writing hacks and writing cheats later to be able to say like, okay, this is how I can get to the current health from, like, you know, this other structure, right? Like if you're able to see everything from one place, you're going to feel a lot more powerful in this realm, I guess you'd say. All right, so we know enough to be able to ascertain like where entities start at, right? Or at least like we know this A280 has some reference to source health. And there's this set of information at the start. Usually what I like to do, right? Usually you would think the first byte is used by something, right? So I say like break on write, or like not break on write, sorry, break on access, because that's going to catch more things. That'll catch writes and reads. And then, yeah, it should be the only breakpoint we have. Awesome. So we're going to run it. And it seems like every frame, just about every frame, or actually probably more than every frame, it's getting called in multiple places. So here's the cool thing, right? When we look through, like, it's all just moving info. Let's do this. Let's say on here, we deleted the breakpoint. We're going to right click on the code that actually called or got hooked on the breakpoint, right? And we're going to say find out what addresses this instruction accesses, right? This is a fun one, right? So now we need to run the game. All right, cool.
Hanging now.
Very good, very good. So we're going to pause it. And so now that we've done that, these are supposedly all the entities, right? I press Control H so it'll show here. Let's actually just do 4 bytes because these are 4 bytes. Interesting. Interesting. So these are all of the loaded entities, I would assume. There might be more than what we're seeing, but these are all the ones that are getting like code called on them. It almost makes me wonder if we could do... Sometimes you can just math it out. Sometimes, like if in memory, if all of the entities are stored one by one, sometimes you can just math it out and be like, you know, this is where they're stored. Yeah. So if I were to do that, I'm trying to look for two that are close. Let's just do it this way. Oop. If you double click it, it adds it to your address explorer. I don't want that yet. All right, cool. So we're going to take the A280, right click, copy, selected, no, copy address to clipboard. All right, cool. Programmer in hex. Let's just take this, let's copy address to clipboard, type in a minus sign and paste. All right, so this is saying it's like 68,000 bytes, 68 kilobytes of entity data. And hey, who knows, maybe, right? But let's do this. Let's copy this, copy address to clipboard, and let's just say plus ACEO. Yeah. So it almost seems like maybe, just maybe, they might not be one after another. And if they're not stored one after the other, then there's got to be some way that the game knows how to keep track of every entity, right? Like, I wonder if there's some sort of list, an entity list, if you will. So let's do this actually. Let's keep this up. Let's keep this up over here. Let's go through and find, if we can, a similar list. So we know A280, that's like where Sora's thing starts, right? If we look at the data before it, I see a couple pointers. BO, 9230. Let's do this. Let's go to these pointers, right? So if you put the square brackets and then the address, you'll go to the address listed. Just want to look through and see, because I see a 59EO, but I don't see that in our list. I see an A260. I don't see that in our list. 8BFO. Yeah, I don't see 8BFO. Yeah, I don't see any of these. So B480. Do I see that? No, I don't see that either. Okay, so this might be something unrelated. So let's do this. Let's go to the A480 pointer that's stored right before Sora's entity, like right before it. Maybe that has some leads, right? 2D82. No, no leads at all. 2D70. 35. Okay, so you know what? Maybe what we can do, if we can't find it this way, let's try a different way, right? Let's go back to the code we were at, where it's like moving the value stored in RCX to ECX. It's like, how do we get, here, let's put a breakpoint here. Let's unpause, hit the breakpoint. Let's figure out, so it's supplied to this function, right? Because it's in the C register, and those are usually parameters. It's usually the first parameter. The value that was in the D register was moved into the C register, okay. The value in the D register comes from the B register after this function. So if we press Control B, all right, cool, our other breakpoint's gone. Let's put one here. Here we are. So we're moving the value in RBX to RDX. Let me just see, 2A70, that is one that we were looking at, very good. RBX. It might have been from that function, but usually functions don't return into RBX. Let's try this. Let's try this. Let's go and I'm going to unbreak there. We're going to put one here. We're going to run it. So RBX is 9820. Okay. It stays the same. So it's before this that it's set. And sometimes you'll just be looking through. And you'll be looking through. And you just won't really see it. You won't really see what you're looking for. And it's okay. That might be the case for us right now. But you know what? So RBX is pushed before this function. Let's do this. Let's go and see like what is pushed. What is pushed here? Oh goodness. Actually, you know what? Let's leave our breakpoint there. Let's toggle one here. Let's just run it. It stays the same. It stays the same. So it's the same from the start of this function that we're in right now. RBX has moved to RCX. Yeah, that's cool. That's dandy. That's helpful. Let's try this. Let's put our breakpoint back here. Let's step out. Let's see. Is it the same thing? It's not. It's not at all. Oh wait. It gets called again. All right. We're in a spaghetti. We're in some spaghetti right here. It's not making sense. And usually when it's not making sense, what that means is let's go look around and find some other stuff that'll help us, right? Because I mean, yeah, we know enough to be able to set our current health and stuff like that, right? It's just kind of, we don't know exactly where it gets the player's entity from, right? And actually, what we could find, if we wanted to find something different, we know the player's entity address, so to speak, right? We know that it's the, let me just go through here, Control G and check my history. Yeah, it was A280. So let's do this, right? Let's go ahead, new scan, right? We're going to search for in hex an 8-byte value, searching for a pointer. First scan. So there's 19 references to assumably Sora's health, or what would you say, Sora's entity. Roxas in this case, of course, but yeah. Nice. Straight up got a dub. Alright, cool. So now, it might be a different pointer. So yeah, it looks like the D990 is going to be Sora's like thing now, because that's the only one that we see. So what I might do is I might just, you know, go ahead, copy this value. I mean, we could go through and we could find a way to verify that, right? But like the only other things are stuff that's not the correct like format, so it's not. My goodness, here. 1E28D990. All right, there we go. Next scan. There we go. 11 values. We can't walk this way, right? Nope. That would be too easy. Once we get to a point where we can walk in and out of rooms, this part will get a little easier. But honestly, all of these might refer to the same thing, so to speak, just used in different ways. So here, really, we could probably use any of these to refer to Sora. Oh man, I wish it would show the whole thing. I just want to see like how far off they are from each other. Let's check something actually. Let's start memory browsing addresses because I have a theory about something, right? So like, okay, that's not falling in line with my theory. Windows. Okay, so that wasn't falling in line. Let's do this. All right, let's memory browse this region because what I want to see honestly with you is I want to see if there's like 3 pointers back to back. Well, in this case, it would be like, yeah, something like this, because it's not possible for us to have a full set of party members yet, so like the other ones won't show up, but I think this one's probably closest to what we're looking for. So we're gonna actually add this, right? We're gonna add this one, and we're gonna call it Sora entity pointer. Put some spaces in there. Okie doke. I'm actually gonna delete this one, and then what we'll do, you know what, here, actually, let's just call this Sora entity, rather, right? And then what we'll do instead is we're going to add a new group. I'm actually gonna change some stuff. So we're gonna take this address, we're gonna put it up here. Perfect, all right, cool. So then I'm gonna actually change this to current HP. And we're gonna change it to be +0. Hold up. Okay, I just realized something. But yeah, we're gonna still do it this way. So we're gonna say +0. We're gonna say 4 bytes. I'm gonna change a couple things here actually. So we're gonna set this to be a pointer. So it's gonna actually refer to the address of the Sora entity itself. Very nice, right? And then what we're gonna do is we're gonna actually add this to another group. This is going to be stat page is what we'll call it for right now, subject to change. Yes, we want address version. It was, if I recall, 5CO, 8-byte pointer to stat page. So we're going to say +5CO. Set pointer. Oh, I know why it's acting weird. So sometimes you have to actually drag the group under what you want it to be under. There we go. Okay, cool. So yeah, this is 4 bytes. I don't want it hexadecimal though. And then we'll copy, paste, change current to max, and set an offset of 4. There we go. So now, for Sora entity, right-click, hide children when deactivated. Right-click, hide children when deactivated. Cool. So now if we wanted to go crazy, let's save this. We want to go crazy. 255, 255, right? Now we're balling. We can't die. We'll never die. We can pause and unpause and it goes back and stays the same for us. I'm going to capture them. So there is no entity for us right now, apparently. Let's try something. Let's see something here. Are any of these set? Here we're going to have to like make address way smaller. It's too big. Oh goodness, all of the stuff is squished. What the world? Very strange. I wonder why those two are set. Oh well. Let's just skip through and see what happens. So I'm curious, right? Because these two, let me see, browse this memory region. Browse memory region. I'm not going to spend too long on this. There's a bunch of references, and if they all work the same, then I'm more than happy with that. This one looks kind of interesting though, but hey, we won't worry about it much right now. So, So I wonder, right, locking on. Let's see maybe if we can find lock on entity, right? So like, let's say new scan. We are not locked on to anything. I want to see if we can find an 8-byte value that refers to the entity we're locking onto, right? So we're going to scan for 0. Everything looks good there. All right, cool. So now we're going to say boop, boop. Actually, I want to do this a different way. Hold up, new scan. So we're going to lock on first. We're going to not start at 0. And there's a reason for this, right? We're going to say 8 bytes, and we're going to say unknown initial. First scan. Found 8 million values. All right, so now we're not locked on to anything. Now we will scan for 0. Perfect, perfect. Do it again. Do it again. All right, cool. So now we're gonna say unchanged value, which sounds weird. We're gonna say compare to first scan. Next. 3 million values that are the same. Jeez, okay. Well, so now we'll just say unchanged value. All right, cool. And now we'll prepare for changed value. Well, actually, here, let's just go exact value and unlock and then go for 0. There we go, next scan. If only we had more things to lock onto. I wonder if that might be more useful. Let me think here for a minute. Let me think. Let's lock on again. Let's say changed value. It's actually still 0, so it should still be unchanged from 0. Yeah, let's do that first and then compare to first scan. Man, we're not getting nowhere. Here, actually, hold up. Exact value, not 0. Ah, fuck. So that means there must not be... Maybe it's not a 4-byte pointer. Maybe it's not what we're expecting. Okay, let's just look for a byte. Let's just look for a byte and say, like, change. Let's just say, like, unknown initial value we're locked on. Say first scan. 35 million. And now we'll assume it's 0. Exact value byte, 0. Next scan. Next scan. Okay, cool. Here, actually, I might as well just 0 and not 0. This is making things happen. 1 and 0. Hold up. There is straight up just a 1 and 0. I also see one that's like 2 and... Hold up. Let's do this. If I set this to 0, it does not unlock on. It seems like it is set by locking on though. And then there's this other one that's either 0 or like 2. If I make it 1. Oh, these are camera styles. Okay, hold up. So we're gonna say camera style. We're gonna say is locked on, I guess. It's not really useful to us yet, but it might be later. Let's actually go ahead, right click and recalculate new addresses, change by offset 0, just so all of them are, actual addresses. They're dynamic and not static, so if we reload the program, they'll still be the same. And then let's see, camera style, right? Haven't tried 3. 3 doesn't do anything. Okay, what about 4? Oh, 4 just doesn't follow you anymore. 4 is unlocked camera. That's cool. What about 5? Okay, 5 is like overhead. Oh, this is like the Winnie the Pooh book camera. Alright, cool. What about 6? Oh, wow. This one locks you to, like, I guess the 0, 0, 0 coordinates, maybe? Okay, that's cool. 7. 7 crashes the game. Well, folks, I suppose this will give us a lot of stuff to work on for the next episode. Considering the game has crashed, maybe that's our sign of the times, but I really do appreciate y'all's time checking this out. I will try to be more fun with uploading, more chronic on uploading and stuff like that, and if you guys seem to like this, I'll keep this ball going. But anyway, I appreciate y'all's time, and see ya.